Hello everyone, my name is Thiago, and in this video I'd like to bring you a few features that were recently launched by Typhoon HIL Control Center, which are developing several steps of our research in just one environment, in just one software. I'm familiar with all of these softwares. I use all of them, and the idea here is not to make deep comparisons of among softwares, but just actually make a demonstration of this path. As a professor, as a researcher in power electronics, I think interesting to show you new tools that are available to us during our research. Allow me to start with a disclaimer. I do not speak on behalf of any manufacturer or brand. Everything in this video is just my opinion. Allow me also to tell you what I have here in my camera. I have here the Typhoon HIL 402 and the launch patch from Texas Instruments 28379D. Okay, returning to the presentation, allow me also to locate you in which part of our research I'm talking about. If you take a look at this picture, you're going to see here several steps of power electronics research, at least here in my lab. We have here parts that are dedicated to modeling, design and sizing, and also to offline simulation, control unit programming, controller hardware in the loop tests. And these parts are located right here, and we have specific softwares for each part. Usually I do the thermal and power losses analysis in LT-SPICE, as well as the AC sweep analysis. Then I move to this PSIM or Simulink to perform a full system simulation with the digital control that I have just been designed. Later, I move to the programming stage in which I use the Code Composer Studio. I can automatically generate code from these softwares, but at least I need to open the Code Composer Studio, load the files, and check if everything is okay. After programming the microcontroller, I move to the controller hardware in the loop test and evaluation, and then I go to the hardware deployment. The idea of this demonstration is to show that we can do all these 4 steps in just one software, which I think is really attractive. And again, this is not a video of comparisons and to show deep details how to model these stuffs. But I think this is quite interesting because instead of switching from software to software and design the same thing maybe several times, you can do just one time here and move to the specific features of the Typhoon HIL Control Center. Moving to the Typhoon HIL Control Center, I'm here with the version 2025.2, and let's discuss the first step, which is the power and thermal analysis and AC sweep. Regarding AC sweep, you can take a look later here how to use a frequency response widget in the Typhoon HIL Control Center software. I'm not so familiar with that, but at least I'm telling you here that it's possible to make this kind of frequency analysis also in this software. And returning here, it's interesting to see that we can switch from perspective, from real-time perspective, and from Typhoon Sim perspective, which is the offline simulation we are looking for. And also I have installed previously the Typhoon Sim standalone software in order to run this simulation in just one environment. It's interesting to see that you have discrete components like diodes, IGBTs, because in this part of the research, which is the power losses analysis, it is interesting to have just one single component for your case. You can also look here at the losses and include here the losses calculation and also the temperature calculation. In this case, different from the LT-SPICE, you need to include here an XML file for the switch and for the diode of this IGBT. You can add manually also here some values. Also on the web page, you may find here an interesting report how to import power losses data, how to create this file, and how to import from datasheet. Just for you to have an idea, I have here the models that I brought from other examples of Typhoon HIL. You can take a look here that there is a file to compute the losses. Okay, And allow me to show you here in one example. I have here one model already in which I have here the IGBTs in a half bridge lag, in a half bridge converter. This is connected to the grid. It doesn't matter now the model because I'm still in the first part of our analysis, which is the power and thermal analysis. And then we have here some things to do, but after doing everything, you can test, for instance, in open loop as I do in LT Spice. I just connect a load here because my intention is to check the behavioral of the components and the power losses and the thermal analysis. But in my case here, I have already the full model in order to show you this demonstration. Allow me to delete this. Okay, I can run the simulation. This is actually the offline simulation. I have here some scope to view some waveforms. Let's wait a little bit. It is preparing simulation. And now it's running the simulation. I can also check. I can already check this. Okay, this is my results. Just a transition here from the mode of operation. This is quite common for any other offline simulator. But taking a look now to the models of the temperature and the losses, I have here some heatsink models, and I can also include here, for instance, another scope and include, let's say, two variables, the losses for switch 2 and also the temperature for, let's say, switch 2. Let's run the simulation again. We can see the power losses of this component and also the temperature of the switch that is internally in the IGBT. Preparing simulation. Let's run the simulation. Okay, I have here the losses and the temperature for the junction of switch 2. The transition here is quite expected because I made such a transition during my tests. Okay, the first part here is actually available to perform. It depends also on how much details you want. You can again change here. You can also take a look at the lookup tables. You can select some variables to see here some graphs, some charts, and check if everything is as you expect. This is interesting in this software. Okay, let's check now the second part, which is the digital control and full system simulation. Actually, I'm already doing this in this model because I was initially evaluating the losses, but in the same time I already have here all my control strategy for this converter, and this controller is fully digital. I have here some rate transition blocks. You can see here inside the block a digital controller made by discrete time transfer function. So this is actually my digital control and my full system because I have here the grid, some loads, and the simulation I'm performing here is already covering the second part, which is the digital control. If I took that in this path here, I had to implement all the switches from a new simulation here in PC or Simulink. I could not import my model from LTSpice to the next software. On the other hand, here in Typhoon HIL Control System, I have everything here with that. Moving to the next part, the programming. In case we are following this path, I need to program my controllers in Code Composer Studio. Alternatively, I can take the files generated by PC or Simulink and just load the files in the microcontroller, but anyway, I need to open and edit or set the Code Composer Studio. Here in Typhoon HIL Control Center, we are going to convert our digital control into code without leaving the software. It's important to note that we need to have installed the Code Composer Studio software before doing this. But taking here the same model that I'm using, now I will convert these blocks into code. I just need to add here instead of bringing these variables from the model to the controller, I'm going to apply here inputs, analog inputs, because now my microcontroller needs to know in which part it needs to read the variables from the loop. So essentially I'm going to replace this, and this also, instead of going to a modulator internally here in the model, I will apply here this to a PWM. One thing that I'm missing here in this toolbox is the digital to analog converter, which is a block very useful to verify an internal variable outside the microcontroller. For soon this will be available in new versions of Typhoon HIL Control Center. Essentially, to generate the code from my controller, I need to make these replacements. My controller is the same, but in order to speed up this video, I already have it here. Moving to this model, I have the same model. I just had to remove the part of that belongs to the power losses analysis, because later I'm going to run these power structures in the Typhoon HIL 402. The controller is right here. This controller is still the same. Now I have all things with the correct parameters in terms of scaling and offset to this launch pad here. Also the generic PWM. I have here the switching frequency, dead time. But the point is, I just took all my model, all my controllers, and put it in a subsystem, which is this one. Then I set the inputs and outputs for the controller, and then I can return here in this setting. In this part, let me first enable this part, and I will disable the power structure because now I'm going to generate the code. So everything here is disabled, and I have here just the controller in this file. Here in the settings, first of all, I need to point where the Code Composer Studio is installed, as well as the C2000 software. I can just check here that is completely okay. If you go here, you can create a Code Composer Studio project, you can export the code, you can check here the status of that. It's checking components. Okay, then you can build and deploy. I'm already converting into code and already deploying all the converted code into the launch pad that I showed you at the beginning of this video. Okay, validation is building initiated. While this is being created, let me show you here the files that the software is generating. It's generating actually the C files, headers, the project itself, some things to run in the flash memory. You also have here other files that is being generated. I don't need to worry about them because everything will be done here in the Typhoon HIL Control software. Okay, I see here that code exported successfully, and then I can now, for instance, just flash the target. Let's wait, and then okay, let's wait a little bit. Doing this, my microcontroller is receiving the code, which is attached to the Typhoon HIL 402, and in a moment I'm going to run the model in SCADA. Let's wait. That's good. Target flash completed successfully. Now my microcontroller is already running all this control strategy, and it is still waiting signals from the ADC parts, and then I'm going to generate the PWM that is going to be sent to the Typhoon HIL 402. In this case, I'm going to disable this part, and then I'm going to enable this part. Let's compile this. Let's wait. In a moment also I'm going to reset my microcontroller because I'm already running a control strategy which is closed loop. Essentially it has been already saturated because there is no power structure, but as soon as I turn on this model I will reset my microcontroller. Let's take a look. So I can have here not this one, let me see, this one. It could be that one. This belongs to the model, so let's open this. I have here just a scope. I have here already set all the output variables because I'm using a block called output settings. I already set here the scaling factors. Here in SCADA, let me change this. Can change to embedded mode. Okay. If I run, for now I have here the grid voltage, inverter current. Actually it started working correctly right now. The load current and the grid current. In this case I'm just injecting an amount of power into the grid with sinusoidal current, but I can see that with this result that it is actually working the code that the software has just been generated. Let's check that in the scope. Before testing that, let me return to the presentation because now we are moving to the last part, which is the controller hardware in the loop test and evaluation. If I turn on again my camera, you can see here the scope as well as part of the setup, but we are testing now this last part because the controller is already running in the microcontroller in the physical launch pad, while the power structure is running in the Typhoon HIL 402. And let me show you, I have here at the current. You can see here the same behavior. In blue you have the current. You can see the same behavior of these things that belongs to the controller. You can see here in the scope. Allow me to try to show you something like this, because now in the controller hardware in the loop, even when I use Typhoon, when I use LTSpice, PSYN, Code Composer, I'm going to use this Typhoon HIL Control Center anyway, because this is part of my research path here in my lab. Then if you take a look here in the controller, allow me to show you here the SCADA, the camera, let's put it here. Actually everything that happens now here will going to happen in the scope, just to show you that this is running in the microcontroller. For instance, if I include some harmonics, let's include some harmonics just to test. This is not the target of this controller, but I will just show you the same behaviors. Let's see, going to see, and the controller was enabled to continue working. It's saturated. Let me reset the launch pad and starting again. You can see, let's try to use a different harmonics. Is not so high, let's say 15%. Okay, you can see here that the controller is actually unstable. Everything was really bad here, but when I reset the launch pad, current is 0 and suddenly the current returns. In this case the controller was able to continue working. Again, this is not the objective of this video, evaluating the controller, but this is part of the research in which I actually can test and evaluate different scenarios to check if my controller is properly designed and if the controller can resist such harmonics and disturbance and other things. Okay, I think this completes my demonstration here. Again, I'm using just one software. I had to disable and enable and modify little things here in the control strategy that I was using since the beginning, evaluating the losses here. Okay, and let me return to the presentation to make some final consideration. I think it is quite interesting to have everything in just one software. Now instead of switching from software to software, we can starting all process of our design research here in just Typhoon HIL Control Center. But I need to say that power losses and thermal analysis are not so straightforward, because you need to include, you need to, for instance, import this data, which is actually, it makes some work for you. And then I consider this just not straightforward as in LT Spice. At least we are not designing and drawing several times the same circuit in different softwares. This is good. CCS, the Code Composer Studio, and C2000 softwares must be installed, but this is not a problem because you are going to have this anyway in case you program with your hands, in case you program from PC. So it's not a problem to have other software installed before running everything here. And in final words, this is quite good. Hoping to see more blocks here, like the, let's see, SPI communication, the digital to analog converters, because this launchpad has more features than we can see here. And I don't know what is this. Maybe I'm not so familiar with that. Maybe this is already available, but I'm not 100% sure. And if you take a look very fast here, you can change from microcontrollers. You can use this classical one, 335, but I'm thinking really interesting to convert all my blocks into code without opening Code Composer, because I can test everything here: power losses, digital control, the full system. I can switch here from one mode to another. I can use later SCADA to create a lot of widgets here to change amplitude, change the mode of operation, modify frequency. This is quite interesting, and this will be really completed to move later to the hardware deployment, which is actually another universe, because you're going to design PCBs or try everything. But considering the path of our research in which we need to move from step to step and move from part to part, it's quite good to have everything in just one software. Thank you for watching. If you have questions, doubts, feel free to contact me. I hope you learned a little bit in this video. Thank you, bye.